This is just an overview of what hypothesis testing is. There are 6 steps to every hypothesis test, and if you just follow those 6 steps, you can always do a hypothesis test. The first step of every hypothesis test is to state the random variable. Remember, that's what you measure, and the parameter in words. Parameter is number you calculate from your population. Granted, we don't have the population, so you can't calculate it, but if you could, this is what the parameter would be. You do state both of these in words. You don't know what the random value of the random variable are until you actually collect the data, and this is all done before you've collected the data. So you actually can state what you want to measure well before you've collected anything. And you also don't know what the parameter value is equal to. We're going to compare it to a number that's out there, that's known out there in the world, but you don't know what the number is. If you knew what the number was, you wouldn't be doing a hypothesis test. But you don't know what this number is for the parameter. You're trying to find that out. So you're going to state this in words. The symbol for the only 2 parameters that you know are the mean and the proportion right now. There will be more that you'll get later in the semester, but right now those are the only 2 parameters that you've been dealing with. The symbol for the proportion is p. The symbol for mean is mu. So you would say my random variable is the number of people who do this, whatever this is, and your parameter would be p is the proportion of the people who do whatever this is. If your random variable is something like measuring the height of people, then your parameter would be mu, which is the symbol for mean, and that would be the mean of the height of people. So again, these are just examples. Once you've stated your random variable and your parameter, the next thing is to state the hypothesis. This is what you're trying to actually do. Again, there are 2 hypotheses. There is the HO, which is that your parameter, whatever it is, either mean or proportion right now, is equal to some known value. Again, that known value that's known out there in the world. HA is that your parameter is either greater than that known value, less than that known value, or not equal to that known value. So if you're asking the question of if it's more than, then you use the greater than. If you're asking the question, is your parameter less than, then you use the less than symbol. And if you're asking the question if your parameter is not equal to or different from, then you use the not equal to symbol. HA again is your alternate hypothesis. This is what you're trying to prove. This is your research hypothesis. This is what you're doing and the whole reason you're doing this. HO is your null hypothesis, and the only reason for this is to have something to assume later to be true and hopefully show it's not. So once you've stated your random variable and parameter in words, and once you've stated your hypotheses, your next step is to state your assumptions. Now this is where hypothesis tests kind of change, because an assumptions depend on what hypothesis test you're doing. So they always depend on what it is. If you're testing proportion, you have certain assumptions. If you're testing the mean, you have different assumptions. And these assumptions are things that are true that we hope are valid. If they're not valid, then this test isn't valid. So if they're not true and checked, then you can't say that the conclusions of your hypothesis test are valid. So you want to go through those and check on those. Again, they depend on what your parameter is. So as an example, if you're doing proportion, then your first assumption is a random sample is taken. All hypothesis tests have that as the first assumption, by the way. Your second assumption is that you've met the properties of a binomial. Remember, there are 4 properties of the binomial. And the last one is that n times p being the known value of your proportion, is greater than or equal to 5, and n times q, remember q is 1 minus p, is also greater than or equal to 5. The reason for the 5 is that it tells us we have a large enough sample. So you want to make sure those assumptions are true, and if they are, then you can move on. And now you actually can go collect data and do the calculations. You've collected no data up to this point, and now you go and collect data and do all your calculations. All the calculations will be done using technology. We're using R, but you can use other technology in the world. But in this class, you're going to use R. And if you're doing a proportion test, then it's prop.test, and then you put in parentheses the information you need. And if you're doing a test of the mean, it would be t.test, and in parentheses you put in the information you need. Once you've done the calculations, it'll give you something called a p-value. So when we get to the conclusions, that p-value is what we use to make decisions. If your p-value is less than alpha, alpha being your level of significance that was picked based on the consequences of a type 1 and type 2 error. If your p-value is less than that consequence, that alpha level, then you reject HO. If that because that means you got an unusual thing happening. If your p-value is greater than alpha, which means you didn't get an unusual thing happening, then you fail to reject HO. We never say we accept HO. If you were going to accept HO, you wouldn't have done the hypothesis test in the first place. So you always want to say you fail to reject HO because you really wanted to, but you couldn't. Once you've figured out your conclusion, you can actually interpret the information. So the last step of every hypothesis test is the interpretation. If you rejected HO, then that means you had enough evidence to show your HA, and you say that in words, whatever HA was in words, is valid. So you would actually in words say there is evidence to show blah, 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 blah is valid, whatever HA says. If you fail to reject HO, then there's not enough evidence to show HA is valid. Again, you'd say the HA in words, so that somebody reading this would know what your conclusion is and not have to go back and find out what HA was, or even what HA means. So this is kind of the steps of it. You never show HO is true. That's not the purpose of a hypothesis test, is not to ever show HO is true. It is to try to show HA is true. And either you can by rejecting HO, or you can't by failing to reject HO. And this is the basic steps of every hypothesis test. And I suggest you try to work on these steps when you do any problem.